Tony's house, and you'll you know it'll all happen. The key thing that this does is if you don't know the blower door number for a house, you don't know the right size HVAC. Now, it's not as big of a deal for California as it is for colder climates, but 60% of gas usage in the US is in 8 states in northern climates. So we have to figure that out. And ideally, California will use a method that is applicable elsewhere rather than, you know, being laughed at by Midwesterners or whatever. So I'd love to see you guys do something that we can just say, hey, let's move this program here and have it work, instead of being, well, this is California only. Particularly in colder climates, if you don't know the blower door of a house, your load calculation is, no joke, plus or minus 70%, which means running a calculation is basically pointless. You might as well guess. If you have energy use on a house, you vary that to about plus or minus 30 instead of plus or minus 70%. And if you can get to have a blower door and energy use and do an interview with a client so you understand what their thermostat settings are and things like that, you're down to plus or minus 10%. So this is important for a couple of reasons. First off, comfort. The smaller the piece of equipment you can put in, and then the more speeds it can have, so it has a throttle instead of an on-off switch. If it runs at low levels all the time, it makes houses far more comfortable. It's called mean radiant temperature, another geeky topic. A bunch of free chapters in my book you can read and figure more out about that. So delivering comfort for consumers is super important. The other thing is we need to make, and this is more important, we need to make HVAC contractors comfortable sizing things down. What they don't want, so again, not so much a problem with this climate, but if it's 5 degrees out, they don't want to get a phone call, hey, my house is not heating, it's only 55 or 60 degrees. They have to go out and replace that piece of equipment for free during their busiest time, when they literally make most of their money, is the very hot, very cold parts of the year. So we need to reduce the risk for them and for the homeowners and make everybody happy. And doing a load calculation with the blower door is the path. Now, the beautiful thing about doing that is in most of the country, you're going to get if you do a load calc that way, so the smallest commonly available furnace that's multiple stage, variable speed, is 60,000 BTUs. The largest available residential heat pump is also 60,000 BTUs. So you're going to be in the heat pump land, pretty much for sure, every time. Or at a minimum, you could do a hybrid with a heat pump on top of a furnace, which drops gas usage 50 to 90% depending on the house and the configuration. So this is what we found, oddly enough, is the key, but people need to be educated about what it is, understand what it is, so the homeowners need to understand, the contractors need to value it, and there needs to be a business model around the whole thing. Otherwise, you get what we've seen everywhere, which is boom bust of a program going in, everybody gets trained, a few people use it, program ends, and everything goes back to status quo. So we need a business model to do that. And it's a sales process more than anything. We need to be able to sell this stuff. So HVAC 2.0, to pull all that together, is basically a business model for HVAC contractors to educate customers, run blower door tests, size things correctly, and end up selling a bunch of heat pumps, not because they're trying to sell heat pumps, but because it is the natural solution. It's an outcome, not a goal.